Okay, so we're in chapter 19 and section 19.4. Unlike in other sections, we have some theory. So with the sample deviation, we could have a curve that has a normal deviation. How do you spell deviation? I don't know. Deviation. Maybe. Okay, if that's true, if I have a normal deviation, that means that the curve is shaped in such a way that if I go out 3 standard deviations, the mean minus 3 times the mean plus 3 times the standard deviation, with the mean being the guy in the middle, that I'm going to have 99.7% of the data entries inside that interval. Okay, and if I go out 2 standard deviations, so there's my mean, I got some curve, looks like that, and I go out plus and minus 2 standard deviations, then I'm going to have 95.4% of the data between those points. That was good. That's just Marvy. 95.4%. Is that what it says? All right. And if I look out only one lousy standard deviation, x bar minus a standard deviation, mean plus a standard deviation, then I'm going to, inside there, I'm going to have 68.2%. Now, who made these things up? I have no idea. Percent of the data points are going to be there. If that's not the case, then my deviation is not standard. So, for example, we take the grade distribution in this class. Would that be a standard deviation? Would that be a normal curve? Okay, so a normal curve would say I got something like that. My average is a C, and then I got B's over here, and I got A's over there. Is that what my grade distribution going to be for the class? And if this were a 4-year school and we had 500 people in the class, yes, it would be. The professor would do that, and the number of A's you'd have would be very slim. There'd be very few A's, but there'd be a shit pot of C's. Okay, this is a community college. This is a tech math pre-calculus class divide. So you know, when we look at the curve, it'll probably look more like that. And those will be my A's, and my B's will be here, and I might have some C's and some D's. And if you didn't bother to come to the final, then you're probably going to have an F. But other than that, if you showed up for the final, you probably can't have an F. Okay. So the grades aren't going to be a standard deviation. Okay. When you look at this class, but if we took all the English classes at Iowa Western, all 30 sections of them, and put the A's together, would that look like a standard deviation? Would that look like a normal curve? Yeah, it would. Yeah, it would look more or less like a normal curve if we did that. Okay. So now the issue of the problem is, I have a data set. I know the standard deviation. Is the data set a normal distribution or not? Yes or no. So that's the only issue to be figured out in the problems that we're doing. So we'll start with number 2. And calculate the mean, the sample standard deviation rounded to 3 significant digits, and find the percentage of data points at plus or minus, let's say, deviation, and determine whether it's within 2% of the plus or minus 1% criteria for normal distribution. So we're not even doing it, we're not even looking at the 2 standard deviations or 3 standard deviations. We're just going to look at 1 lousy standard deviation. Are we within plus or minus 2%? And if we are, then we're going to say yes, it's normal. All right, so my data set, 27, 27, 38, 43, hike. Anybody going to go to the game on Sunday? Yeah? The game at the Unidome, the only one that counts. I am?
Yeah. Don't argue.
Okay, no problem. I can fix that.
Talking about the national championship game?
Yeah. Oh, they got some really cool T-shirts over in the student center with the national championship game on it. 1, 2, 3, 4, 5, 6, 7, 8, 9. They will be if we lose. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so first thing we need is the mean. And I shut down my Excel spreadsheet, so I'll open it back up maybe. But in the meantime, I'll guess the mean. Get out a calculator. Okay, so
7 isn't in there.
what?
Say 7 is not in there.
67 isn't on there?
Not problem 1. You're looking at problem 3.
Oh, I went in.
67
So I don't have problem 1 or 2 on the board. Is that what you're trying to tell me? So if Dustin would have kept his mouth shut long enough for me to write the data set down, I would have got it right. Is that what you're trying to tell me? Just so we have the right message being sent here. 82. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're going to guess 44. So if I guess 44, I'm going to get minus 17. And then minus another 17. And then minus 6. And then minus 1. And then plus 13. And plus 32. 32 and plus 38 equals 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 equals 5.25. What did I guess? 44? So the real number would be 49.25. Alright, then we need a sample deviation, square root of, divided by 7. Okay, so I got that. So I go back to my calculator. 49.25 minus 27 equals squared times 2 plus parentheses. Let's just do it. Parentheses. 49.25 minus 38 close parentheses squared plus parentheses. 49.25 minus 43 close parentheses squared plus parentheses 49.25 minus 44 close parentheses squared plus parentheses 49.25 minus 57 close parentheses squared plus 49.25 minus 76. Oh, I didn't put parentheses on there. I'm hosed. What's the number?
What's that?
No, I can't use that. I don't have any light over here.
20.8.
It's 20.8? Okay, so 20.8.
That's the X of 20.8.
All right. So the 20.8. Okay, so now I come back over here, 20.8. So now I want to know 49.25 plus or minus 20.8. All right, so that's going to be 20.8 is not right.
Yeah, that's what X is.
Twenty point eight. Where's my calculator? 49.25 minus 20.8 equals 28 point something. Okay, that's better. 28 point something. And when I come out to the outside, it's going to be 60, 70, out to 70. All right, that being the case, there's 1, 2, 3, 4 guys not in that range, and there's 4 guys in that range. So that means plus or minus 1 sample deviation. I have 50% in my curve. I'm supposed to have 68.2, so no is the right answer. I would have had to, I don't have enough guys inside to be a normal distribution. Okay, so that was 1. So I'm skipping 2 and I'm going to 4. Number 4. So I've got 48, 50, 51, 57, 62, 69, 70, 73, 73. All right. And we want to know, why doesn't this scientific calculator, oh, look at this, a statistics calculator. Oh, isn't that nice? Okay, I'll just use it. 48 plus, how do I add the data in? Add. Okay. 48 add. Clear memory, clear all, clear everything. 48. Enter data. How do I enter data? View, scientific, view, statistics. 48. 50. Oh, okay. 51. 57. 62. 69. 70. 73. 73. Okay, so I've added all my data. I want the sample delete out. Okay, so I'm 10.2 S sub X, 10.2. All right, so I need the mean. There's the mean. Boom. The mean is 61.1. 61.4. Okay, so I use the mean, and I can go down to 51 0.2, so that means the guys here are out. And I can go up to 71 point something, so the guys that way are out. I have 4 in, and I have 5 out. That's less than 68.2%. And this is not a normal distribution. So 2 not normal distributions in a row. All right, going on to 6. Number 6, unless you want me to do 5. 43, 47, 52, 56, 70, 57, 69. Okay, take my calculator again, clear everything. Clear. Clear. How come I'm not clearing? Clear. Oh, there we go. That cleared everything. Alright. 43. 47. 52. 56. 57. 64. What is my mean? So my mean is going to be 53.1, we'll call it 53.2. 53.2 going to be the mean, and the sample deviation 7.5. Okay, so when I go x bar minus that, I get view to standard calculator. 53.2 minus 7.5 equals 45 point something 7. And when I go x bar plus the sample deviation 60.7. Alright, so I've got a line sitting there. I got a line sitting here. I've got 2 out and 1, 2, 3, 4 in. 1, 2, 3, 4, 5, 6. So I've got 4, 6 in, and what's 4, 6? That's 2/3. 66%. Is that plus 66.6%, right? Is that plus or minus 2%? Of 68.2? The answer is yes. Yes. This is a normal distribution. Okay. Oh, excellent. Oh, just Marvy poo-poo. We'll do number 8. We'll do number 9. Number 9. Okay, so we have a data set. And, oh, no problem. Huh. We're given the mean, 67.9, and we're given the sample deviation, 1.39. Alright, so x bar minus 1 standard deviation, 66.5. X bar plus the standard deviation, 68.3. We look at our data and we see that we have 6 and 21 that doesn't count, and on the top end we've got 29, 18, and 3 that don't count. Yeah, what's the problem?
Your x bar plus s of x would be 69.3.
Think so?
Yeah.
69.3. Okay, does that change anything? Yeah, it does. So that means this 29 wouldn't be there. All right, so I got 6, 7, 15, 18, 1 to carry. I got 48 that are out. Okay, now, how many total do I have? It doesn't tell me. Darn. I got 40, 50, 60, 70, 80, 90, 100, 110. 110, 120, 130, 140, 151. N is equal to 151. So I'm going to go 48, 151 minus 48 divided by 151. And see what percentage I have.
How did you get to 48?
I don't know. Did I do it wrong?
I was just wondering how you got to
2, 4, 2, 3, 4, 8.
Where did those numbers come from?
Those are the ones that are out. So when I look at my data table, I got a who's below 66.5, the 6 and the 21. Who is above 69.3, the 18 and the 3. The sample, the number. That's how many numbers there are. The frequency means how many numbers have that.
Okay, I didn't
Particular
realize
guy.
the frequency.
Yeah. So I got 151 people here, or whatever it is I have. Okay, so 151 minus 48 equals, divided by, that's pretty silly, because we all know that that's totally wrong.
Press C.
What is it? Press E?
No, C.
I did.
No, I didn't.
I did all but, I did everything but that?
It's C.
I didn't hit C?
No.
Alright. 151 minus 48 equals, divided by 151 equals 68.2. Is 68.2%, is that plus or minus 2% of 68.2%? And the answer is yes. So I have a normal distribution. Excellent. That was that number 9?
Yep.
Okay, you want me to do 7?
We want you to do x plus or minus 2 s of x.
Oh, wait a minute. So we have to do 2% and we have to check it again. So yes for plus or minus 1. Now we got to check it for plus or minus 2. Okay, so the mean 67.9 minus 2 times 1.39. Is that what I was using before? Yeah, it was. Okay. And then 67.9 plus 2 times 1.39. So those are the two calculations we want to do.
You get 1.39.
It's given to me.
That's s of x.
It's given to me in the problem. I'm just blessed, I know. 67.9 minus 2 times 1.39. 91.6. 67.9. Well, I guess it's the other way. Minus 2. Wow, am I ever hosed or what? Times. Wow. Stupid calculator. Can't even do math. What? 67.9 minus. There's no parentheses. View. Scientific calculator. So I could have done this in my head before this calculator is going to get it done. 65.1. All right, 67.9 minus 2 times. See, the scientific calculator is doing it right, 1.39. 65. No, it didn't. Except I put a minus sign in instead of a plus sign. You idiot. 67.9 plus 2 times 1.39. 70.68. All right, now again, I'm looking to see how many guys are in and how many guys are out. So there's a 6 that's out on the bottom, and on the top there's a 3 that's out for a total of 10. So 10 divided by the 151, which was what I have, is 10 divided by 151 equals, that was good. That was just marvelous. So if 10 are out, 151 minus 10. Okay, so 141 divided by 151 equals 63.4%. Now, I am supposed to be plus or minus 2% of 95. Am I? Yes. Yes. Plus or minus 2% of 95%. Therefore, normal distribution.
You mean 93.4, not 60.
Oh, I hope so. Yeah, 93.4, right.
Okay.
All right, we happy with that? Easy enough? Only easy enough if you have a calculator that does it. If you have to do it manually on a dumb calculator, then it's a pain in the rear end. But as long as you have a TI-36, and I'm pretty sure the TI-36 Pro, somebody have one of those, it works just fine. You know, you put it in statistics mode, it's going to give you the answer, and life is going to be wonderful for you.
Or if you have a computer, you just use the
That's right. You know, use Excel spreadsheet. I like that better. Okay, thank you very much.